Hello. So now we'll be solving 1552. Hmm. Let me check. Yeah. If we are given I baskets and the position of each basket is at, okay, position of I gives you the position of the basket. Okay. And you have M balls. You need to distribute the balls into the basket such that the minimum magnetic force is maximum. Minimum magnetic force is maximum. So, okay. Basically, we need the distance between each ball to be maximum, and we need to find the minimum of them. So here the answer would be 4 minus 1, which is 3. And the 7 minus 4, which is 3. So the minimum of that is 3, right? Okay. Hmm. Okay. So, so this seems like a value binary search. We have to minimize the maximize, right? Return the minimum magnetic force between any. The Murdy has placed equilibrium. The minimum magnetic force is maximum. So we have to maximize the minimum distance between two balls. That's what we have to do. And for that we can, yeah, this is just a value binary search. So what we have to do is take the maximum distance. Okay, the number of balls is two, right? Yeah. So, uh, yeah, M should be, yeah. So take the maximum distance. So that is 7. And then the minimum is 0. The maximum is 6. 7 minus 1 is 6. Minimum 0. And then you start the binary search. So yeah, you try to minimize the value from 7. And we have to keep in mind the number is this thing. Mhm. I think that's what we have to do, but yeah. But first we need to create the function to check whether a number is valid or not. So what I mean by that is, let's say the distance, minimum distance has to be 4. Okay. So we have to check if we can make the minimum distance 4. In this case, we cannot because we have three balls and we have, yeah, we if we place the first ball in the first basket, we place the next one in the seventh one, and then we can't place anything in between. But we have three, so, so let me get started with coding. For position, hmm, so it's define valid. Uh, let me call this valid max. Valid max. I'm just gonna change this to Vim mode. Give me a second. Um, where is the, wait, is there something wrong with this? Settings. Yeah, well, I zoomed it and I forgot to zoom. Yeah, yeah, so for the distance, yeah. So valid max, take an integer x, and then we can check whether it's valid. That. Hmm. How do we check whether it's valid? So let's say we have, I need to think for this. Say we have 1, 2, 3, 4, 7. 1, 2, 3, 7. These are positions. And then our M is 3. So we need to place 3 points such that the minimum difference is maximum. Let's say we have the number 4. So if we start from the first one, we have to check. So 1 plus 4 is equal to 5. So in this array, we have to check if there's something greater than or equal to 5, and there is 7. And we have to find 7. So this we can, I think we can binary search this, right? So, yep, I think that's the way to go. So you bisect right. Okay. Hmm. But suppose we're doing it for 3 now. Hmm. Start with 1, we find 3. Okay. Hmm. And once we arrive at this index, that index plus 3. So let's say we don't have a 3 here. So it's this index plus 3. So it's 3 plus 3. And we have to check. If that's also valid, then we return true. Now I get it. Okay. So this previous is equal to 1 for I and M. For I and M, you gotta check if, yeah, we have to check if previous plus the input X is valid M times. Okay, we gotta change the previous, right? So here, first of all, this is not 3. It should go to 4. 4 plus 3 is 7. Yeah. It's 1, 4, 7, yeah. Not 1, 3, 7. Sorry for the bad explanation. If I and M, so index is equal to bisect bisect right of uh, the number previous plus x comma the number position. Hmm. Then if if the index is lesser than n, previous is equal to position index. I think that's right. Okay. And if it's not, if the index exceeds n, then we return false. If everything's passed, we return true. So this returns a Boolean value. Boolean. Okay. So let's check this function if it's working. So let's do print valid max of let's just we we'll also do that for four. I'm using vim, right? Yes, it's four. So let's check this out. Okay, so I forgot the range. Did I mess up the did the array come first in this function or is it the other way around? I think it's the array first. Okay. So yeah, we have a problem here. See, it should be true, right? So let's print what's going on with the index. Let's print right. So yeah, this is the problem. Yeah, we should start from. Okay, we have to do it two times. One and then two times. Yeah, we do it two times first. Uh, complete. Uh, false. Hmm. List index out of range. Okay, so let's just print the. Let's just print the index for now, and let's see what's going on. Okay, so went to four. Four plus three, 7. And 7 does. Okay, I don't. Yeah, it should be bisect left. So if 7 does exist, I don't know why I'm doing it right. Be bisect left. Yeah, now it should be fine. Because let's say we have 7. we're supposed to include it, and now what I did was I excluded it. See, now it's fine. So I could implement this manually, but might as well use it. So basically, what I'm doing now is, let's say we have the number 3, and m is also 3. So if we start with, uh, let me just clear this up. 1, 2, 3, 1, 2, 3, 4, and 7. So let's say m is 3, and we're checking if the validity for 3, if we can place the m balls at 3 distance each. So we place the first ball here, obviously, in the starting. And then the second ball is 1 plus 3, so it is 4. So we're checking if there is a bucket at the fourth distance or anywhere after the fourth distance. So let's say we had a 5 here. So that bisect left what we've done would return a 5. Yeah. But in this case, we get a 4. Then 4 plus 3 is a 7 again. And we get 7. So that's why it's valid. And that's what this function is doing. Okay, now moving on with the rest of the solution. Why did I submit this? Yeah, it's the test case. Yeah. Okay, so let's get this function out of the way. Now we have L comma R. Now this is straightforward binary search, right? So L is 0, and then it's uh, it's max of position minus 1, but I can consider it to be max of position. It's fine. Doesn't make a difference. Okay, and now, so while left is lesser than right, uh, we need to maximize it, right? If mid is equal to L to the star to standard binary search. So if valid max of mid, is this a value binary search? If it's valid, we have to maximize it. So the left would be mid. Then if it's invalid, the right would be mid minus 1, and then we finally just return right or left. Both is fine. So let's see what happens. So I think we got a time limit exceeded here. Might have to check what's going on. If it's just then mid, see what's wrong. It's not. Okay, why am I printing mid before I even assign a value to mid? Okay. There we go. 3535. So yeah, but it's less than or equal to, right? I think it'd be probably a silly mistake. I'm just, not paying attention, just going with it right now. Kind of busy. But it's still, hey, no, 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 what am I doing? So I'm assuming it's the same question. We first checked it for 3, which was valid. Then we checked it for 5. So 5 was invalid. Okay. So 3 is valid. 5 is invalid. So 3 plus 5 by 2 is 4. Right. Right. If 5 is invalid, uh, 3 is valid. L is L is equal to 3, and then R is equal to 4. So 7 by 2 is still 3. 7 by 2 is 3. And if it's 3, I'm setting it to 3 again. That's the problem. Okay, so if valid of mid, okay, if it's invalid, we set it to mid minus 1, right? Then R is the answer. Okay, come to 4, and then 4 again. Wait now. When I can use a previous element, then hmm, I know mess up these kind of things sometimes. I could simply use a previous thing, like if I can just have a previous is equal to minus 1, and then if valid of max and mid not equal to previous, do that for sure. So here I can have previous is equal to, I can have previous is equal to mid. Yeah. Can definitely do this, but it doesn't seem right to me. I mean, it's right, but it doesn't seem clean to me. What is this one? Valid of max and mid not equal to previous. What? Why is it true for 5? Can be false. Something's wrong with my valid function, bro. I forgot to comment it out. It is false. 5 is false. Okay. What was the problem here? Mid valid max is mid, not 3. Yeah. So 5 is false and become 4. Right. Okay. So Yeah. The problem is with this. So L has to be valid, not R. That's fine. But why do I need a previous though? That's the question. Yeah, so let's this out in deeper. Have I sorted it? It has to be, hasn't the positions sorted? Sometimes these guys, okay, my bad. Why was it right for this test case? Yeah, I think I should sort the positions. I, I assumed it was sorted, and hopefully now it should be fine. Hmm. Okay. Why is it valid for 21? Why is it valid for 21? Invalid for 21. Valid here. So let me debug this. Let me print my position just to make things easier. So 2057 and 4. So 3 times 22 plus 21. 22, 57, 74, 79. The 22 plus 21 is 43. So we would come to 57. 57 plus 21 is 67, 77, 70. So we would come to 79. And then we're out of, yeah. So print my index, check what's going on, every iteration. 0, first of all, yeah. Hmm. You don't always start with 1. That's the thing. That's my mistake. It's position of 0. Yeah. I thought you always start with 1 because of the test case, but I'm just being clumsy. So expected is 5. So first of all, is, is print Let's check if our function is right now first. If this is right, I'm assuming that's where the problem is. If it is right, yeah, we have to maximize this. Okay, so print L is equal to mid to the font. Okay, so what we can do is, if it's valid, we can have previous is equal to mid. Okay, right? And then we can change this here. I feel like I shouldn't need a previous, but then why is this? All right, have to return previous, right? I think that's what the problem was. I was returning the wrong thing. Okay, there's still something here. Right. Okay, yeah. So we also when we do that, in that case we also have to check for equal to. And now it should be right, yeah. Yep. Yeah. There we go. I really like this problem. Had fun solving it. Yep. Uh, how do I do it without the previous two? Let's assume I don't need it. Right. The problem is 3 comma 4, right? 3 plus 4 divided by 2 equal to what is equal to 3 again. And what? Yeah. So we need it's a thing. I had faced a similar problem before. Six. That'd be 3 by 2 is 1 plus 3 by 2. Oh, right. I didn't even change this, right? What's the problem? Now it should be less than equal to no. Yeah, so L by 2 is 3 by 2, and then 4 by 2 is 2. No, no, no. 3 by 2 is 2. So 3 by 2 plus 2 by 2 is 2. 1 plus 2 is 3. 3 by 2 plus 4 by 2 is equal to 3. What power 1 times 4. Oh, I think we do that for the overflow, right? Integer overflow. Yep. So we can do L plus R divided by 2. Yeah. This is the final answer. A little bit cleaner. Yep. There we go. Thank you guys for watching. Hope you enjoyed watching it. Good night.